Okay, so this week we're going to be going over basic input and output and files and folders. The slides this week were created by Gaurav Nayak, and they'll be presented by me. Thanks to Gaurav for taking the time to create these slides. It really helps me out. Cool. So input and output. Inputs are a way to accept information from the user, whereas the output is a way to provide the information back to the user. The inputs and outputs both could be via the command line user interface or via files. Remember the print function we've been using? That's a classic example of output in the console. So we've already been playing with output in at least some context. So anytime we have been doing the print statement, that's one way that we can produce an output. That's an output to the console or an output to our logs for later viewing, but it is an output nonetheless. So, believe it or not, we've already been doing a little bit of what you're going to be learning this week, but that's of course not the only way that we can do inputs and outputs. We can also use files and folders and all that good stuff. So if we want to get input from a user, we can use the input function in Python. The input function stops the execution of the code and gives the control of the program to the user. The user is prompted to enter the data using their keyboard, and once the user enters the data using the enter key, the control returns to the program, and the function input returns the entered data in the form of a string, which can be processed further or displayed back to the user. So the way we can use it is we have the input function here, and we'll have some text that we want output to elicit that input from the user. So in this particular example, we have the input function. Within it, we have a string, wrapped in quotes, where we're asking for a number. So we're saying enter the number, and then we're going to store the results of whatever the user enters back into the user input variable. So it's something to note is that we always want to store the value returned from the input in some sort of variable using our assignment operator. And we can print that out back to the console here. Something again that I want to reiterate, and we've got it highlighted in this slide for a reason, is that this is going to be a string. So no matter what the user enters, it's going to be a string. It's going to be a string value. So even though we're asking for a number and the user's entered a number 50, this is actually stored in a string variable. It's hard to tell here because we're just printing that out, and so it doesn't show the quotes or anything like that. But it is important to remember that the data type of any input that we get returned from the input function will be a string. And that's important for a number of reasons, because you want to, if you're expecting some sort of special data type, like you want it to be a number or a floating point number, you'll have to make sure to do your casting operations to get that into a floating point number so it can be used as one or a integer number. Because otherwise, if we try to do like 50 minus, if say we have some number initially saying that's like 100, we ask for a number from the user, we try to take 100 minus 50, we're going to get an error there because it's saying that the 50 entered by the user is a string. But we can just relatively easily cast that back to an integer and then do our mathematical operations. Just always remember that that's the case because that's something that trips people up all the time, but we can remedy that with some simple casting. Not seeing any questions in the chat so far, so I'm just going to keep moving along. Again, continuing on inputs from the user, the input function always treats the input as a string. Again, it's worth just reiterating 100 times, really. We want to make sure that that's very clear because it's something important to remember. We can use the isInstance function from Python to check the data type of an argument with a second argument, and it'll return a Boolean result. So in this particular case, we're calling isInstance. We're taking the user input, and we're wanting to check we can consider it like is user input an instance of this data type. So in this particular case, we're saying is user input an instance of a string data type, and this will output true, as we can see down here. So we've done the same thing where we're eliciting an input from the user, and we're getting a number from that user, and the user enters 50, but is user input data type a string? True. So we're printing out here is user data type a string. We're using the isInstance function to check if user input is a string, and that outputs the Boolean value true. So user input is in fact a string value. And then we can check the type of a piece of data using the type function, where we just do type and pass in the piece of data that we want to check the type of it, and then it'll output that type. So here we have type, we're printing type of data, and then the type of user input, and we're getting type of data as class string. So again, very worth just going over 100 times basically that any user input is a string. Even though the user has entered a number, it's going to be stored as a string in the variable in the back end of Python. So let's see. Looks like we have a question. We use greater than or equal to 1. Print for output, i.e. information we wish out. Yeah, sorry, I guess I misread the greater than or equal to. So yeah, we use print for output to output information to the console, just like we have here where we have print, and then we have, all of this stuff inside that print function is being output to the console, and we can see that down here when the function is run. And then yeah, for input, we do want the parentheses. So that is that's a good thing to call out. You do want to include your parentheses, because it's a call to a function. Anytime you call a function, you need to make sure that you add your parentheses at the end. And for the user input, you'll always want to put a string inside of the call to input, because that's what will be output to the console to give the user an idea of what you're looking for here. So of course, if we just did input without any string in it, it's still going to accept a user input, but the user is going to be really confused about, like, what are you asking for here? If you haven't entered any text inside of that input function, it's not going to be obvious to the user what you want them to enter. So so for the input function, you'll always need to have the parentheses. Any call to any function or method will always require the parentheses after it. And then, yeah, the argument that goes within those parentheses is basically what you want output to the user so that they have an idea of what you're trying to get them to enter. So great questions there. Cool. I'm not seeing any other questions in the chat, so let's just keep moving along. So now that we've got input from a user using the input function, we can also read inputs from a file using the open function. So the open function takes 2 parameters, a file name and a mode. So the file name is the path of the file in the system, along with the file name and its extension. And the mode could be a number of things, but the mode basically indicates whether or not we're reading the file, appending to the file, writing to the file, creating a file, or any of those types of situations. So for R, for the second argument, and these will all be string arguments, and we'll see examples of this in a moment. But for R, that's the mode that we use for reading the file, and it returns an error if the file doesn't exist. This is the default, so if you don't include that argument, it'll default to R. A, again, as a string for the second argument, is for appending the data into the file, and it'll create the file if it doesn't exist. So say we already have a file like myoutput.txt, and we want to add to that output, then we would use append mode, which is just A for the mode. So W is for writing into a file, and it'll create the file if it doesn't exist. So an important distinction between the write mode and the append mode is that the write mode will overwrite all of the contents of your file. So again, if we had that output.txt file, we would anything that's already in our output.txt file will be completely overwritten. So we're not going to append to it. And this is, say you have a process that runs daily or something, and it just generates a basic report. In that particular case, you would want to use the W argument, because you would want to make sure that you're overwriting the contents of the report. Otherwise, you're eventually going to have a very long report. If you kept using append mode, you're eventually going to have a very long report that just doesn't work out very well, because you want the latest data. You have to scroll all the way to the bottom of your report, ignoring everything in the first few lines. You'd also need to have some way of knowing which date the report came from, all that good stuff. So in that case, it makes more sense to just do a write, because it'll overwrite all the contents of the file with the current date's report. Whereas, for append, say it's just like, you have a process that runs to check if you have new users to your application and you want to append them to a list of users or something that's persisted in a file. You can use the append operation there so that you're not losing all the users that you've gotten on previous runs of that program. So one other thing we can use is the X mode, and the X will create a file and it'll return an error if the file already exists. So if you have a use case where you want to make sure you're creating a brand new file and you don't want to you want to make sure that you're creating a brand new file and you don't want to overwrite all the contents of that file, you can use the X mode for creating that file. So say, the use case of running a report or something, say you want to have distinct files and your file names are written, say like, report and then the date. You might want to use this method, the X mode, to make sure that to make sure that the file doesn't already exist, because if it already exists, that probably means your process already ran, and you can save some compute resources by not running your process again. So you would use the X mode to see about creating that file first. If the file already exists, it'll return an error, and then you can handle that error accordingly to just not run your process if it already exists. So that's an example of maybe when you would use the X mode. So again, the open function takes 2 arguments. The first argument is a file name and the path to that file from wherever you're writing your code. And then the second argument is the mode, whether it's read, append, write, or the X one for creating a file and returning an error if it already exists. So let's see, questions. Should modes be defined during the coding process? Yes, absolutely. Whenever you create the open function, you'll want to specify the mode. And we'll be showing examples of all of how exactly it's used here in a moment. But yeah, you definitely do want to specify your mode. One of the concepts in Python is that implicit or explicit is better than implicit. So while R is the default mode, it's better to just be explicit and always specify the mode that you're using. So if you just did open with a single file name in it, that would just be reading that file. But if you do open, and then the file name is your first argument, comma, the mode R, that's explicit, telling someone who's reading your code, okay, you're only reading this file. And same goes for all the other modes. If you want it to be any of the other modes, you absolutely have to include the mode. All right, another question. Can you please use an example, such as using Microsoft on a work environment for append and write modes? So yeah, I mean, so just speaking to an example of those, like if you're starting, if you are, say you've been working on a project or something, you've been writing up a Word document and you're coming back to it to continue writing that Word document. That would be like an append use case. You don't want to overwrite everything you've already done in that Word document. You want to continue where you left off, basically. So that's like an append use case. But if say you have some use case where you need to generate a you're writing some notes. Say you're writing some notes for your day, like a to-do list for your day. You've already done your to-do list for yesterday, right? So you would want to go in, delete everything that's in your file, and then write your to-do list for today, because what's in it already is from yesterday. So you go in, delete all that stuff, and then you put in what you want for today, and that would be like a write use case. Kind of considering in a work environment. That's how you could think of them.
David, can I step in? Sure. Sorry for interrupting. What I wanted to have is this. You said with append, you don't have information, you don't have the timing if there was an append mode into a code, into programming. As for writing, it will give you information. I wanted to know when somebody, let's say we working together on the same program, then everybody can come in, put in information. Will I know if somebody appended or brought some information? Who's that person? What time did they do that? Am I going to have that type of information or not?
So that would be entirely dependent on the logic of your code. Basically, you would want to make sure that you're including logic in your code that's maybe including timestamps that people are appending to the program. Whenever you write something using the open function, whether it's append or the write mode, it's only going to write exactly what you tell the program to write. It's not going to give you any additional information of this was written at this timestamp, unless your code includes logic to make sure that it's actually including that timestamp in that write operation.
Okay, thank you.
Yeah, great question. Yeah, so for a use case like that, it would be a good idea to include, in your string that you're writing out to your file, include like timestamps of like, maybe who updated it, when they updated it, all that good stuff. All right, not seeing any other questions in the chat, so we're going to keep moving along. So input via files, here's the syntax and the examples that we were just talking about. So open is generally preceded with the key, preceded by the with keyword to handle file operations easily. The reason is that we're saying like with open, and then we create it as a certain file object. You can open a file without the with function, but if you do that, you have to make sure to close your file later on. So it's often easier to just do the with open, because then after the lines tabbed underneath your with statement are done executing, it'll automatically close the file for you. Because you have to be explicit about opening or closing a file when you're working in any programming environment. So in here, this will just make sure it'll open the file, do the operations, and when you come out of that indentation, it'll automatically close the file for you. So open is generally preceded by the with keyword to handle file operations easily. Read lines creates a list of each line in the file, and read will read the entire file and return the text. It's not a good choice if the file is huge. So say we've got, so here's an example. Say we've got a file that's named example.txt. So the first argument to our open function is going to be the file that we want to read, which is example.txt in this case. Then the second argument to open is the mode that we want to open that file in. In this case, we're doing the R mode, which stands for read mode. So yeah, the second argument is the mode that we're executing it in, and that's, we can get that from the previous slide. So we say with open, giving the necessary arguments, and then as file object. So here we have to give a name, some variable name to the file, so that we can reference that variable within our with function. So here we're saying with open example.txt and read mode as file object. Then inside of that with, we're saying we're going to assign the variable lines. We're going to assign that equal to the file object.read lines. So we're taking this file object and we're reading all the lines from it. And then outside of our with statement, we're going to print those lines. So when we do that, we get a list of each line in the file. So here we have, I am the input file line 1, and then I am the input file line 2. So this is a list of the various lines within our example.txt file. So this is how you can use the read function or the open function. This is most often how you're going to see it used, is something where you have with opening the file and then as a file object. Or you can always, this name is completely arbitrary. It doesn't have to be file underscore object. You could have as f, as file, as my file, whatever you want it to be. Just make sure that whatever you use here is then how you're referencing that file within the with statement, within the lines that are indented under your with statement. And then, yeah, here we're doing read lines. So just another thing to call out here, when you do read lines, it returns the lines in your file as a list. And if you just do read, it would return it as just one long string. So it would just be like, I am the input line 1, the new line character, I am the input line 2 without the brackets. So it wouldn't have been in list form. That's the difference between read and read lines. All right, looks like we have another question. What happens if a user wishes to open a file in a certain mode that has not been programmed for? Will an error message appear? I'm not certain I'm following the question, but maybe what you're asking here is, say like someone tries to open example.txt in read mode. They open it in read mode, but then inside the code here they try to write to that file. That's going to be problematic. They will get some sort of error there. because they've opened it in read mode, not write or append mode. So they can't write or append to that file. So if they tried to call a write operation on that file, it's not going to work. So if that's what you're getting at, then yes, an error would result in that particular case. Perfect. Yeah, great question. Yeah, make sure that the mode you're using is the one that you're trying to use, right? Like if you're trying to write or append to your file, use the W or A modes respectively. If you're just trying to read from the file like we're doing here, where we're doing read lines, then the R mode is exactly what you want to do. Perfect. All right, so now input via files, write in append mode. Append mode will add the text into an existing file and won't overwrite anything. It can be used on an empty file as well. Write mode will add the text into the existing file and erase everything which was there before. So let's consider a use case where we have an original file of example.txt. And this is the file that we saw on the previous slides. So I am the input line 1 and I am the input line 2. This is our original file. It has 3 lines. The first line says I am the input line 1. The second one is I am the input line 2. And the third line is just a blank line here. So this is our original file. If we go into append mode, so let's just compare the lines of code here. We're saying with open example.txt in append mode in this particular case. So we're passing the A as file object. And then in this one over here, we're doing the write mode. We're doing with open example.txt in write mode as the file object. So basically these lines of code, these first lines of code here are exactly the same, the only except for the W and the A. So we're doing write mode on this side, append mode on this side. And then within that, within there, we have file object.write, I am the new line, and we're doing that same thing on both in both cases, whether it's append or write mode. So now when we look at the resulting output for append mode, a new line is added to the end of the file. So when we execute this program, we take the original file and we just add I am the new line to the end of the file here. With overwrite mode, write mode, we overwrite the existing data. So here we completely got rid of I am the input file line 1 and I am the input file line 2, and we only have I am the new line in our result file. So hopefully this is a nice like visual representation of exactly the difference between append mode and write mode. And you'll just need to consider, what's best for your use case whenever you're working on your programs. So let's see. Questions. In read lines, should the lines be mentioned in the brackets? So real quick, going back to the read lines operation, read lines will return the lines in brackets. Yes, it's not something that we're explicitly doing here. It's not like we created these lines in brackets in our file or anything. All we have in our file is I am the input file line 1 and I am the input file line 2. But what read lines does is it takes those lines, separates them into individual elements. Each line is an individual element in a list, and it returns that list. So that's what read lines does natively. It's not something that we have to like explicitly mention or anything there to include those square brackets. And then for the next question, what does the \n mean in the append mode? So \n is actually a new line character. So if you ever want to add a new line to your file or to any output, just print basically a blank line. That's a \n. \n just creates a new line. So something we'll notice here on this slide is when we read the file object, when we read our example.txt file, the first line has a \n at the end of it. That's because there's a new line character at the end there, and then the second one doesn't have a \n in it, and then at the end of it because that one didn't have a new line character at the end. So in this particular case, what we're saying is add a new line character at the end, and this is where we get this extra blank line for line 4 here. And this is why in this particular case for the write mode, when we have the \n, we still have another blank line on line 2 here. So yeah, \n is it's a special character. It's interpreted as a new line character. So when you read or write anything in Python or in any programming language, it's going to pick up those new line characters. There's actually, there's a couple different ways that you can create new line characters depending on the operating system you're using. But generally in Python, the \n is what you're looking for to create that new line character. Yeah, and it just has to be explicit in Python, right? Like, to us, we know that when you're typing something, you just hit the enter key and it creates a new line and it brings you to a new line. There has to be something in the back end for the operating system of your computer to know that there's a new line there. And that's what the new line character is. So another question, what do you mean by overwriting? Writing more or on top of? Yeah, so overwriting means to like take what you have, erase it, and then write whatever you're writing anew. So here we overwrite. So we take the existing data. So, again, we're using the same starting file in both of these cases. So in write mode, we overwrite, we take what's already in it, delete it, and then put in our new line, which is the I am the new line here. So notice how in the output, when we're using our write mode, we don't have the I am the input file line 1, I am the input file line 2. We don't have those lines in our result file for write mode because we overwrote the file. We took everything, deleted it, and then just put in our new line. Whereas in append mode, we just added a new line to the file. We didn't overwrite it. So it's basically writing on top of, to put it in the terms that that your specific question asked. Append mode would be writing more because you write another new line there instead of deleting the existing lines and then putting in your new line. Perfect. Not seeing any other questions in the chat, so going to keep moving along. Did I miss a slide? No. Okay, cool. So files and folders. Sometimes it's required to read and write into multiple files that are present in a directory or subdirectories. With the current knowledge, we'll write the path of every file and perform the operation for each of them. What do we do in cases that there are hundreds of folders and thousands of files inside of them? Python provides an easy way to iterate the folders and subfolders in a path using the library OS. So we can import the library before using the functions within OS. So this is kind of like what we saw with arrays back a few weeks ago. You need to import the OS package into your file using the import function. So we do import OS at the top of our file, and then we can use the OS package throughout our file. So so just make sure that when you want to use the OS package, just import it first, and then we'll see here, we're going to see some examples about how we can use the OS package along with what we learned last week with loops and iteration to go over folders, subfolders, and objects inside of them to easily process a bunch of different files instead of having to specify each individual path to each individual file that you have in your directory or in your system. So the way we can do that is using the os.walk function. So to iterate all the files and subfolders in a directory, including the subdirectory and subfolders, use os.walk. So os.walk is invoked like we have here. So first off, remember another thing to keep in mind is that you will need to import OS at the top of your file. It will always need to come before your first use of the OS package. And then we can use functions from that package. In this function, we're going to do the walk function. The walk function takes a single argument, and that's the root path that you want to iterate. So you have to give some sort of root path that you want to iterate over. And then what os.walk does is it returns a tuple of the current folder, the folders within that folder, and then the files within that folder. And these will all be, the first one will be a string, the folders will be a list, and then the files will also be a list. So typically when we do that, remembering back to last week and how we talked about iteration and iterate and all that good stuff. So whenever you have something that returns a tuple, you can have multiple values in your for each basically. And this will pull out the individual values of your tuple. This is called unpacking a tuple. So since os.walk return on each iteration returns a tuple with 3 values in it, we can give 3 values to unpack our tuple here, separated by commas. The first value in that tuple is always going to be root. The second value of that tuple is always going to be our folders. and the third value of that tuple is always going to be files. These variables here can be, these names are completely arbitrary, but of course, Gaurav writing these slides wanted to make it very informative, as should you whenever you write your code. And he made sure to give these variables informative names. So like the root path, the list of folders, and the list of files. But you do always want to have 3 here whenever you're doing the os.walk, unless you're going to have logic within your code to handle the tuple itself on each iteration. So in this for loop, we're saying for root folders files in os.walk, our root folder, we're going to print the root folder, we're going to print the folders, and then we're going to print the files. So we have our root path. On our first iteration of the loop, we have the root folder. And that's the folder that we entered here. And so each of these is like a new iteration of the loop. Each time you see the C colon, it's like a new iteration of the loop. So first iteration, our root is the root folder that we specified in os.walk. This is the list of folders within there. We have 3 folders, folder 1, folder 2, and folder 3. And there are no files within that. So we just get an empty list for the files print that we're doing down here. So then now we have on the next iteration, we're going to go into the first folder in the list of the previous iteration, basically. So now our root folder is root folder, folder 1. So now we're within this folder 1. Inside that, we have another folder. So we have subfolder 1a, and then we also have a file, file 1a.txt. So then on the next iteration of the loop, we're going to keep diving deeper. So this is a depth first approach. So we always go like as deep as we can before we go breadth, which is like you can kind of consider a file structure like something that has depth to it. It's something that as you go further into a file structure, you're going deeper into that file structure. So we're going to go depth first. So we start out at the root, we go into the first folder in the list. Then if there are any folders in there, we go into that folder. If there are any folders in that subfolder, go into that folder and keep going down all the way. And then we'll like make our way back up to the other folders along the way. And then steadily make our way over instead of going, across our folder structure first. So second iteration, we have root folder, folder 1, subfolder 1a, and file 1a.txt. So that means this subfolder 1a is within folder 1, and this file 1a.txt is within folder 1 as well. Now, since there was another subfolder within folder 1, we're going to go into that. So now on our next iteration, we're diving into subfolder 1a. So now we have our root path being root folder, file 1, and subfolder 1a. Within subfolder 1a, there are no folders, but there are 2 files. So no folders, we get an empty list. There are 2 files though, so we list out the 2 files there, file s1a.txt and file s1b.txt. Now that we've hit the bottommost depth of folder 1a, on the next iteration, we're going to go up, check if there's anything else in folder 1. There's no other folders in folder 1. We already went through subfolder 1a. So now we're going to go back up to here, and we're going to go to the next folder here, and we're going to end up in folder 2. So now we're in our root folder, folder 2. There are 3 subfolders within that folder 2. There's no files there. Now we're going to dive into folder 2a because that was the first file in folder 2, or the first folder in folder 2. There are no folders or files in subfolder 2a. Next iteration, we go to folder 2b over here. There are no folders, but there are 2 files, so those are output there. And then folder 2c, and there are no folders, no files in subfolder 2c. And now we go back up to folder 3 up here. There's no folders, no files, and now we're done because there's no more going back up this chain. There's no more subfolders to iterate and dive through. So I know this seems like a ton of information and it's really complicated. It absolutely is. I highly, highly, highly encourage you all to use this same exact code here on your own system. But maybe all you'd change is the root path just to see it iterate over a folder structure that you're familiar with. So change the path that you're iterating over, and then just use the same exact code to see how this works. So I Can't encourage that enough. It's a great way to get some practice with it. Really, I think it would help. It would be nothing but beneficial to you all if you just take the time to do exactly, go through each of these slides and copy down the code just to get some practice with it yourself. Yeah. All right. So questions. Looks like we've got a few. So starting from the top, do we always have to iterate in the order root, folder, and file? So not necessarily. So yes, in a way, and let me clarify that. So in this particular case, when you create the iteration here, you do always have to have the first one is always going to be your root, the second one is always going to be your files, and the third one, or the folders, and the third one is always going to be your files. That's only for the for statement itself, that the first is root, second is folders, third is files. Only in this case does it have to be in this specific order. Our print statements within here, though, these could have been in any order we wanted. So we could have printed files first, then root, then folders. The logic within here is totally up to us. The logic within the for loop is totally up to us. But the way that you unpack the tuple returned by os.walk always has to be the root path first, the folders second, and the files third. So I hope that answers your question. Great question. Looks like we've got some drawing on the screen. I'm gonna real fast stop sharing and reshare. I'll have to figure out how to just delete that in the future. Cool. So let's see, back to the chat. Okay, so next question. It is like a set of Russian dolls. In order to get the inner doll, one needs to pass through the first one. Yeah, that's a great way to think about it. Yeah, like a folder structure is kind of like a set of Russian dolls. You have to, you keep, they're nested within each other, and in order to get to your subfolders or a doll that's within another doll, you need to open the first folder or the first doll and then get to the second one. That's an excellent way to think about it. Yeah, great analogy. I like it. Should this be used using a decision tree? So you certainly can implement a decision tree type architecture here. So it's not necessarily, I wouldn't think of it as something that absolutely has to be related to a decision tree, though. Decision trees are technically a different, they're like a different kind of data structure. They're actually used in machine learning type use cases, where you're going down and you make certain decisions based on certain files. But it does help to think of folders of the os.walk as like walking a tree. It's a tree, it's a folder tree, but not necessarily a decision tree, only because we're not making decisions in there. Of course, you can implement logic within your for loop to make decisions at each stage of like your root, your folders, and your files. So, if it helps to think of it like a decision tree, absolutely keep thinking of it that way. Just keep in mind that a decision tree itself is actually like a different thing that you might learn about later on if you get into machine learning use cases and things like that. But it is basically a tree that you're walking. It has we could consider like the current, like the root folder as like the trunk, and then folders within that are like branches coming off of the current trunk that you're working on, and then the files as the leaves on that branch. So that's absolutely a great way to think about it, is kind of like walking a tree from trunk to branches to leaves. I hope that's helpful. And yeah, this is great. Thank you so much for the examples and analogies. I find that's very helpful for some people, and I'm not great at coming up with them myself. So yeah. Meant a tree though to help get to the right path. Yeah. So yeah, thinking of it as a tree is great. And you can kind of implement decision tree type logic within your walk statement there. So yeah, absolutely, loving it. Thanks for the analogies. I think that's very helpful. All right, not seeing any other questions, so we're going to keep moving along. All right, more on OS. We can use the OS package to check if a path exists using the os.path.exists function. We can check if a path is to a file or a directory using the os.path.isFile. We can use it to check if a file is empty using the os.path.getSize. And we can see some examples below where we first checked if a file is available in the path and then check the size to avoid Python exceptions. So we're not gonna yet learn about exception handling for a few more weeks, but for now we do want to try to consider how to avoid exceptions. So let's look at these examples here. So first off, here we have some path here. So first off, again, import OS. We always want to import OS at the top of the file. Any import statement should always go at the top. We'll talk about packages in a future week, but for now, just know when you're importing OS, it goes at the top of your file. We'll specify a path. We're assigning the variable path to our C drive random path. Then we can use the path exists function to see if that path is an actual directory path in your file system. So we can check if os.path.exists, our path that we assigned up here. If that path does exist, this will evaluate to true, and we'd execute the line of code on line 4 saying directory path is correct. But if os.path.exists path, if this evaluates to false, meaning that this path does not exist in your system, we're going to print incorrect directory. So in this case, when Gaurav ran his code, he didn't have this random path at the root of his C drive, so it output incorrect directory because this path did not exist. So this evaluated to false, and then we had incorrect directory here. This is useful because oftentimes you want to make sure a file exists before you try to read, write, or whatever to that file, especially read, because you want to make sure you're reading from a file that actually exists. You can write to a file that doesn't exist because the write operation will create the file for you if it doesn't exist. All right, great. So then down here, again, importing OS at the very top of the file, we're giving a file path. So the reason that this is prefixed with an R, and this is for anybody who has a Windows machine. If you have Linux or Mac, you don't have to worry about this R. But for anyone with a Windows machine, if you want to include these backslashes, so notice up here, he had the C colon and then a forward slash. He didn't need the R there. The reason you need the R for the backslash is because you want it to be considered as a literal string, and you don't want these backslashes to be considered an escape character. So if you ever use a backslash like this within a string, and you don't prefix that string with an R, it's considered an escape character. So it'll basically like escape the letter after it. It gets a little complicated there. That's a way that you can include. So see here, he has like single quotes in this string. If he wanted to include a single quote within that string for whatever reason, he could use the escape character to make sure that doesn't close the actual string here. So that's getting a little complicated. Don't worry too much about it. Just know that if you want to use backslashes within your string to separate your folder structure, like Gaurav is doing here, you must prefix it with an R. People with Windows will need to keep that in mind. People with Mac or Linux, they can just use forward slashes all the time. Just one of those things, differences between operating systems that you have to keep in mind. All right, so if os.path.isFile, file path, and os.path.getSize, file path is greater than 0, the file is not empty. So first, what we're checking is this a file? So we want to see if that's a file or a directory. If it's a file, it'll return true. In this particular case, it is a file, so this will return true. Then we want to check, is that file empty? And we can do that using the get size. So with the os.path.getSize, where we pass our file path as the argument, this will return the size of that file in, I believe, bytes. So if there's any contents in the file, it'll return some value greater than 0. If it's a completely empty file, there's nothing in it, it'll return 0. So then we can know that if this evaluates to true, so it is a file, the first one is a file, and using our logical AND operator to combine these two Boolean expressions into a bigger Boolean expression, os.path.getSize is greater than 0. That means it's a file and it's not empty. So we would print file is not empty. Otherwise, we print either the file path is invalid or the file is empty. And then we check os.path.isFile, file path. We want to check if it's a file. So if it is, then we're going to print out file path is valid and the file is empty. So in this particular case, when Gaurav ran this code, this Boolean expression evaluated to false here. But remember, with the AND operator, both of these Boolean expressions have to be true in order for this larger Boolean expression to evaluate to true. At least one of them was false, so it came down into here, and that's why we print either file path is invalid or the file is empty. Then we want to check, well, is that file path invalid, or is the file empty, or is the file just empty? So we're checking if os.path.isFile file path. Here, if this returns true, that means it is in fact a file and it's not an invalid file path. Then we would print file path is valid and file is empty. So that's what we get down here. File path is valid and file is empty. So what this tells us is that this file path that Gaurav gave to file 1a.txt, that file does exist, but there is no content within that file. So what happened here is coming to this if statement, the first one here, this Boolean expression evaluated to true, right? Because os.path.isFile file path, that evaluated to true. It is a legitimate file. But then we wanted to check, is that file empty, using os.path.getSize for the file path and seeing if it's greater than 0. That was not greater than 0, so this evaluated to false. Since we used the AND operator here, both of these would have had to evaluate to true for it to be true. But since one of them evaluated to false, this larger Boolean expression evaluates to false. So we came to our else block. In our else block, then we printed out that the file path is invalid or the file is empty. So then we want to check, is it a valid file path, using os.path.isFile file path. This evaluated to true again, but since we don't have anything else to our Boolean expression, this makes this whole Boolean expression true. So the code within that is executed, and file path is valid and file is empty is printed to the console. So I know this is a ton of information. The class is really starting to pick up at this point. Please let me know if you have any questions. But again, try creating some file paths on your system and executing this code on your own system. The best way to understand how this stuff works is to just play around with it yourself. So I can't recommend that enough. Please do take some time to go through the slides, write out the code that's in all these, create some folders in your system, and just play around with it. Great. I'm not seeing any questions in the chat, so I'm going to keep moving along. Oh, I didn't know this was here. So see how we use the R behind the file path? R is used to include backslash in the string. So that's what I had called out a little earlier. Yeah, because we have the backslash in the string, we need to prefix it with an R so that backslash isn't interpreted as an escape character. So there's a question, can't exercise without creating files. So you can do the exercises without creating the files, but just keep in mind that this one isn't really going to do much for you, because if you don't create the file, then this os.path.is file, this will evaluate to false, and then this will also evaluate to false. I mean, it is a great way to to start out without the file, see what the behavior is, then go in and create the file, see what the behavior is, then go in and add some information to the file and see what the behavior is. So you definitely can do the exercises initially without creating the file, but the best way to really get the most out of it is to play around with all scenarios where the file doesn't exist, where the file where the file is empty, and then where the file exists and is empty, and then where the file exists and has some data in it. So, playing around with all different scenarios in that use case is going to be the best way to really understand what's going on inside the code. It's a great question. All right. So replace. If we need to replace a string with another, what if we need to replace a string with another and create a new file? We can use the replace and open function. We can use replace, and the open function can be used in a single line using the with loop to read and write at the same time. So say we have this example.txt file. I am the line 1 with incorrect spelling of Python. So we misspelled Python here. It's missing the H in it. And then I am line 2 with the same mistake in spelling of Python, this time in the middle. So, no H in our Python here, it's just misspelled. So if we want to correct that in order to get the corrected example, what we can do is we can open our example.txt in read mode as file input object, and open our correct example.txt in write mode as our file output object. So then for line in file input object, correct line equals line.replace. So we're iterating over the lines in our file input object. And then in that line, we're going to replace Python with Python, the correct spelling. And then we're going to take that, and then we're going to take our file output object, and we're going to write the correct line to the output object there. So this is kind of an example of how we can do, how we can read from a file and write to another file all at the same time without having to first read and then write separately. Yeah, so just again, play around with this. It only stands to help you understand what's going on here. Yeah, this just shows that you can do both at the same time. Just something important to note is the difference in names of the object references. So we have file input object here for the object that we're using in read mode, and then we have file output object here as the file that we're using in write mode. And then just keep be careful of which one you're using within your code here. So we're iterating over the input object, and then we're replacing Python with Python, and then we're going to add a new file to the file output object with each iteration of that loop using that corrected line. And what the replace operation does is it basically searches in that line, and it'll try to find what you enter as the first argument, and it'll replace it with whatever you enter as the second argument. So we were searching for Python, we found Python, and we replaced it with Python, the correct spelling of Python. Cool. So additional resources. Again, can't recommend enough going through all of these. I hope you all have been taking the time to go through all of these. I think it only stands to benefit you in understanding the assignments and the contents that we're going over. So the first one here is from Tutorials Point, and it explains the different modes of accessing the file and various functions in the OS package. The split function, you're going to need to know about the split function for completing the assignment. So hopefully we know enough about programming now to kind of pick up something else without it being part of a lecture specifically. So if you have questions on it, do let me know. But the split function reference is right here. So you'll need to go to this reference and learn about the split function. What it basically does is you call the split method on a string, and you pass in something in that string to split on. If you don't pass anything, I believe it splits on a white space, just a blank white space. But if you wanted it to say split on a comma or split on a slash or whatever, you would pass that in as a string to the split method. And then finally, we have some file operation practice questions. Again, please take the time to go through all these. It only stands to benefit you. This stuff, W3 schools and Tutorials Point are great ways to learn programming and actually get practice. One of the best ways to learn programming is really just to keep practicing with it. So W3 schools, W3 resource, and Tutorials Point are excellent. Great. So not seeing any other questions. So let's move on to the assignment. Okay. So week 7 assignment. There's a folder named college provided to you, and I'll be sending this after the lecture when I send out the assignment details and everything. So there's a folder named college that'll be provided to you. The folder has many subfolders, and these folders may or may not have files inside them. The folders inside college have the name stream 1, stream 2, and stream 3. These folders have files named as studentdetails.txt and facultydetails.txt, which has information for students and faculty respectively, given as an ID, an enroll year, their name, and then their name. So using the comma here to separate those values. So this is considered like a comma separated values or CSV file. Note, even if the folder has a file inside them, the file may be empty. So keep in mind that your file might be empty. Hint, hint, use the get size thing that we've been talking about so far, and that'll help. So in question 1, write a program that accepts a file name as user input and creates a file inside the college folder if the user writes a valid name. Otherwise, print invalid file name in the console and exit out of the program. So again, using user input here. So you're going to use the input function to accept a file name from the user. Make sure it's not an empty name, basically. We want to make sure that it actually has a real name. If you want to check that it ends with like .txt or something, that's great, not necessarily required. Just make sure that they enter something valid and it's not just an empty string. So the user can press enter instead of writing a file name, and this is a failure condition because if they just press enter, that enters an empty string, and that would be considered a failure condition. Make sure that you have that failure condition in your code. So as another tip, use the exit function to terminate the code. So you want to make sure that the string entered by the user isn't an empty string. And if it is an empty string, exit the program with exit code 0. This is how you would use that. You just exit and then the code you want it to exit with. If there are any questions on that, please let me know. So question 2, modify the program in question 1 to write a header inside the file if the user enters a valid name. So that header inside that file is going to be this string right here. So you'll just want to make sure to write that to the file that was created in question, that was created as a result of question 1. Question 3, write a program to iterate through all the folders inside of the college folder and read the data from the files that write inside the file created in question 2. So you're going to have ID, enroll year, and name are given in the file itself. So that's, ID, enroll year, and name are in the file itself. Then what you need to do is determine the stream. So the stream is going to be the subfolder that you're in, stream 1, stream 2, or stream 3. You're going to also need to determine whether they're a student. If they are, then you would just put yes, or in that column. If they aren't a student, then do no, and that would be based off of that's based off of whether it's student details or faculty details. And then you're going to do faculty, again, a yes or no for whether or not they're a faculty member. And then the source file path, you want to take the file path where you got that information from and add that into the file. So ID, enroll year, and name are from the given files. So they're already in student details and faculty details.txt. Stream is the name of the subfolder. Student, if the data is inside the student details file, write yes for student, no for faculty. Faculty, if the file name from where the data is getting read is faculty details, write no for student and yes for faculty. And then the source file path is the full path of the file from where the data is being read. So that would be like your college stream 1 faculty details.txt. So the expected output of this is the expected output that we want is basically shown right here. So this is what you're looking for as the final output of your file. So I know it is a very complicated assignment, but you do know everything. The only thing that you'll need to look up is the split function and maybe the exit function. But this is all you really need to know. This is how you use the exit function. But the only thing you'll need to learn about is the split function. Otherwise, you know all the things you need to know to complete this assignment. So let's see, questions. Do you have to name root, file, folder, and subfolder, or they will be created as such as we create them? So, kind of back to the os.walk situation, os.walk, you do need to give some sort of name for root, folders, and files here. And then you'll need to iterate over to make sure you'll need to iterate over, as mentioned here. So I'm going to give you a zip file that contains this college directory and all of the subfolders in there. So you won't need to create those files and folders yourself. We already have those created. Gaurav created all of those, so I'll be sending those along. An example of how to start the assignment will be highly appreciated. I'm not really sure about what you're asking for there. All I can really say is that you need to go through and just follow the assignment details. You'll start out the assignment with taking a user input and then checking whether or not that is that user input is valid. If they entered an empty string, it's invalid, so we'd exit the program. Then you're going to have to go through and you'd create that file. After you create that file, you'll put as the first line in that file this string here. And then after that, you're going to use the os.walk function to iterate over all of the folders and files within the college folder in order to get the other details like stream, student, faculty, and source file path. that's really all I can tell you at this time. You know, a very important part of learning how to program is just struggling through it yourself. I don't want to give away answers here because that doesn't really help you to learn how to program. Just, you know, give it a try. If you have questions, let me know. But, you know, go over the slides again, use the resources that we've given at the end of the slides. It's going to benefit you in understanding how these things are used. And if you haven't already, please, please, please take the time to read the textbook chapters that were supposed to already be read for this week. You know, doing all those things gives you a lot more information, and it only stands to benefit you in your understanding of how to complete the assignment and the understanding of the concepts themselves. And if you still have questions after that, feel free to reach out to myself, Gaurav, and Braj, and we will get back to you as and when we can. Yeah, I know it is going to be a difficult assignment, but you know, they're meant to challenge you. Yeah, great. So that's it for this week. I don't see any other questions thrown in the chat, so we'll go ahead and call it for this week. Thank you everybody for joining and for your time. Again, I will upload all of this stuff to YouTube just like in previous weeks, and I'll send out the and then I'll send that out along with the assignment and the resources you'll need to complete the assignment, including the college folder. And then we'll talk again next week. Yeah, so I hope you all have a great rest of your weekend and an awesome upcoming week, and I will talk to you next Saturday. Have a good one. Bye.